Hello again. This time we're going to be solving some KVL examples. Remember that KVL, is the sum of the voltages this time around a loop is 0. The sum of the voltage drops and rises more specifically. Okay, so the first thing we're going to do is identify loops. Okay, so you can do this, and this. Now, let's figure out the loops that we can actually solve first. We can actually solve either loop, let's call it loop 1, loop 2, and loop 3. We can solve either one of loop 1 or loop 2 first. So we can do loop 1 is equal to, so we have a -6 because we're going into the -6, and then we've got +5 because we're going into the positive side, and we've got the unknown, which we're going to call as plus minus for now until we are told otherwise. So we got x right there, or more specifically v, and that's equal to 0. Solving this, we get v equals +1. So that means that our convention of +1v was correct. Now let's do loop 2. So once again, we've got a +6 right here, +6, +4 right here, +4, and we get plus x equals 0, x equals -10. And so in this case, we have an entering right here as being negative, like that. Now this one you can solve this way, and we're going to go ahead and do that. So we've got going in this current right here, pretend we're starting here. It doesn't matter where we start. And we got loop 3 equals -1 plus x minus 4, because we are going around like this, equals 0. And we got x equals +5. Okay, so then that means this guy going in this way is +5 volts. Sorry, let me just be consistent here. +5 volts and minus. Now, we could have solved that another way, because there is another loop that we can see, and I just want to draw your attention to it, and that is this loop. Loop 4. Okay, and if we wanted to solve loop 4 for this value right here, we'd just do the same thing. Loop 4, but this time it's -10 plus 5 plus some random number, and what do we get? 5 volts. So we're good here. Okay. Here's another problem. Now, how do we solve this first? So we can do either this loop or this loop first. We can even do this loop, but that's pretty unnecessary. So let's just go ahead and do this loop first. Let's call it loop 1, loop 2, and loop 3. So we get going into this way, -1, going into this way, -5. So the top right here has to be +6 volts minus in this configuration. Now that we have that, that actually doesn't help us with the bottom part. We have to solve this independently. So right here, we've got a loop, and we've got loop 2 going into this way, And so we can just call that plus v. Let's say loop 2. And we've got this guy going in this way, so we can call that minus 5. And that equals 0. So v equals plus 5 in the direction that we had chosen. So plus 5 volts and minus. Now this one, now that we have this 5 volts right here, we can now solve this guy right here. Or technically we could have solved it with using this loop right here, but yeah, I'm just deciding to do loop 3. Loop 3. We've got a, let's say, actually didn't even draw the loop. Let's say it's going this way, counterclockwise. So we've got -1 minus 5 plus v equals 0. And we get v equals plus 6, where we get the plus side being this way because we got the current going this way from our arbitrary loop, and we got 6 volts like that, like so. And yeah, so the moral of the story here is that you can pick the direction of the loop, and as long as you stay consistent, that's a big thing. And you can draw a loop so long as it's a loop, right? So we know that this is a loop. We know that this is a loop, which we used. We know that this is a loop, which we didn't use, right? And those are all valid. Okay?